In data scenarios, we explore real-world industry challenges where AI can make a difference. Each scenario is built around a story, presenting a problem that requires innovative AI solution. You'll engage with tasks designed to tackle these problems step by step, gaining practical skills and insights into applying AI in impactful ways.
Hello everyone and welcome to this data scenario. So you've been hired by MX News, a 40-year-old news company with a rich history of journalism. The company has provided you with their news headlines archive from March 2004, and they need your expertise to identify the 10 most relevant headlines related to climate change and global warming. MX News is particularly concerned about maintaining privacy while handling their data. That is why they've asked for a solution that operates entirely on local resources. To meet their needs, we'll be using a local Ollama text embedding model to build a solution for them. So let me show you how we are going to tackle this problem. So MX News has provided us with a dataset containing news headlines, and our goal is to find the ones related to global warming and climate change. To achieve this, we can perform a contextual search using text embedding vectors. Let me show you how it works. First, we take the CSV file containing the headlines and use a text embedding model to extract embedding vectors for each headline. A text embedding vector is essentially an array of numerical values that represents a piece of text while capturing its contextual meaning. Next, we take the search phrase, climate change and global warming, and use the same embedding model to generate its embedding vector. Finally, we compare the embedding vector of the search phrase with those of the headlines using vector similarity measures like cosine similarity. This will allow us identify the headlines with the most similar vector embeddings, which are likely to be contextually relevant to the search phrase. Alright, so now let's get started. The first thing that you need to do is to download the project resource files from the GitHub. You can find the link to the repository in the description below. Now, as you can see in this repository, we have the Python virtual environment that contains all of the libraries and everything we need to get started with this data scenario. We have the dataset from the MX News. We have a requirements.txt file in case you want to install all of the needed modules. And of course, we have the notebook. This is the notebook that we need to follow along as we go through this data scenario. So now let's get started. In the first code block, as you can see, we are importing all the needed modules. We're going to use pandas. From the scikit-learn matrix pairwise, we are going to import the cosine similarity. And of course, we need our text embedding model. In this case, we are going to use Ollama embeddings. The next thing is to install Ollama on your machine. Let me show you how you can do this. If you go to ollama.com on your browser and click on download, you can download the local Ollama for your operating system. After you're done with the installation, you can go ahead and click on the models. And in here, you have access to all the models that you can download and use on your local machine. The model that we want to use for this data scenario is the large embedding model from Mixed-Breed AI. If I click on it, I can see some documentations about how to use it, and also I can find an instruction on how to install it on my machine. I'm gonna copy this, open my CMD, I'm pasting it here, and if I press enter, I can see that I've successfully pulled this model for my machine. If I go ahead and type Ollama list, I can see the list of all the models that I've already installed on my machine. Now, let me show you how we can use this model. If I go to my browser and have a look at my localhost port 11434, I can see that the Ollama is running. Now, I have access to all the models that I have downloaded on my machine. Let's go back to the notebook. In here, you can see that I've defined Ollama API endpoint. It is pointing to the localhost port 11434. I also created a variable for the model name. I'm gonna run this. I also make sure that I run to import all of the modules. Now let's load the list of the news headlines. So I'm gonna go ahead and create a variable called headlines data. and I use pandas underline read CSV, and I'm passing in the name to the CSV file. Let's have a look at this headlines. So headlines, data.head, and I'm gonna run this, and here is our data. We can see that in our data frame, we have only one column that is called headlines. And let's have a look at shape. We can see that we have 123 different headlines from 2004 from MX News. Now let's load our embedding model. I'm gonna go ahead, create a variable and call it embedding model. I can call Ollama embeddings, and in here I can choose the model that I want to work with. And I'm passing in the model name that I have defined in here. I'm going to type it out and have a look at it, and I can see that I have an Ollama embeddings model. The model is MXBAI, embed large, the latest version. Now the next thing that we need to do is to extract the vector embeddings from the headlines. So I'm going to create a list called headlines, and I will get the headlines and convert it into a list. In this way, I'm going to have all of the headlines stored within a Python list. Then, if we want to get the embedding vector of all of them, I can use embedding model dot embed documents method, and I'm passing in the headlines. If I run this, it might take some time because I'm using the model here. Now I can see that I've used the local embedding model to extract the embedding vectors for each of the headlines. This is a list of vectors. Let's go ahead and create a variable called vectors, and I'm going to store them here. Let's have a look at the first vector. I'm going to run the block, and I can see that a vector of numerical values that are describing the first headline. Let's have a look at the length of this. So I'm going to have a look at the number of elements within this list. Now I can see that each of the embedding vectors contain 1024 elements. Basically, we are describing each headline with 1024 elements or numerical values. Now what I'm going to do is to create a new column in my data frame. I'm going to call it vectors, and I'm just going to go ahead and add the vectors to our data frame. Let's have a look at our data frame. I'm going to run this, and I can see that for each headline, I have a list of numerical values that are describing the contextual meaning of each of them. Now that we have the embedding vectors for each of the headlines, it is time to use the embedding model to generate a 1204 dimensional embedding vector related to the phrase global warming and climate change. This is our search phrase. I'm going to go ahead and create a variable called search phrase. In here, I'm going to have global warming and climate change. Then I'm going to create a variable called search vector. And again, I'm going to use my embedding model to find the embedding vector of this phrase. To do this, I'm going to use the method called embed query, and I'm passing in the search phrase. Let's have a look at the search phrase vector, and I'm going to run this. Here I have the embedding vector of our search phrase. Amazing. Now the last thing that we need to do is to use the cosine similarity measure to calculate the similarity between the search vector and each of the embedding vectors of the headlines. To do this, I'm going to create an empty list called cosine similarities. And I'm going to use a for loop to loop through every vector that I have in my vectors list. Now I'm going to create a variable called similarity, and I'm going to calculate the cosine similarity between the search vector and the vector that I have. And now let's go ahead and have a look at the similarity. I'm going to run this. Now I can see that for each of the vectors that I have, I have a numerical value describing how similar each vector is to our search vector. But I can see that this value is inside of a list that is already inside another list. So I'm gonna index this value out. Let's rerun it. And here we have the similarity. Now I'm gonna go ahead and say cosine similarities dot append similarity. And after the for loop is done, I'm gonna go ahead and create another column in my data frame. I'm gonna call it similarity, and I'm gonna put the cosine similarities list in the new column. Let's have a look at our data frame, headlines, data. I'm gonna run this, and here we go. Now in our data frame, we have the headline, the vector of the headline, and the similarity measures. That is basically the similarity of each headline to the phrase global warming and climate change. Now, if I want to find the top headlines that are related to the search phrase, all I have to do is to sort the data frame by similarity score. In order to do this, I can easily say headlines data dot sort values, and I'm gonna sort the values by similarity. And of course, I put the ascendings to be false. I'm gonna update my data frame and have a look at the first 10 rows. I'm gonna run this, and here we go. Now in this way, I found 10 headlines that are related to global warming and climate change. Amazing. So that was it for this data scenario. I hope you guys have enjoyed it. Don't forget to subscribe my channel to see more of these data scenarios. See you next time.